we want to see if there's any natural numbers x, a, and b such that x to the a plus x to the b equals x to the a plus b. And keep in mind, natural numbers are 1, 2, 3, 4, 5, and on and on and on, basically all positive integers. So how do we approach this problem? Well, we have an x to the a over here and an x to the b over here. Maybe we can substitute these for new variables to make it a little bit more cleaner. So how about we say that j is equal to x to the a and k is equal to x to the b. So that means we can rewrite this equation as j plus k equals x to the a plus b, equals, I'll write it over here, x to the a plus b is just the same as x to the a times x to the b. This is a basic exponent property. When you have the same base and they're multiplied together, the exponents just get added together like this. So x to the a plus b equals x to a times x to the b. And x to the a, as we said before, was j, and x to the b is k. So we can write it as j times k. So now we have simplified the equation from this to this. J plus k equals jk. So how do we solve this now? Well, keep in mind, this is only one equation and we have two variables. Normally, we would just say that this would have an infinite number of solutions. However, we're just saying that x, a, and b are natural numbers. We're restricting ourselves to natural numbers, which now means that this has a finite number of solutions, not an infinite number of solutions. So we have to solve this in a way that gives us those solutions. And the way we can do that is by using Simon's favorite factoring trick. Now, what is that basically? Well, first, let's just put everything on one side. So let's just subtract the j and the k to get 0 equals jk minus j, not y, minus k. We can factor this in a certain way that'll give us certain answers. That'll show us the obvious answers. And how do we do that? Well, we know that it can be factored into two forms. Let's put these two sets of parentheses so we can factor it into two terms. Now, how do we do this? How do we factor jk minus j minus k? Well, j and k are going to get multiplied together. And since we know how to multiply two binomials like this, we know that j is going to be somewhere over here and k is going to be over here. That way, when we're foiling this, we know that when we FOIL the first terms, j and k, we're going to multiply these two together to get jk. Now, we also need a minus j. Well, j and k are getting multiplied here, but j has to get multiplied by something over here to get minus j, and that term will be minus 1. Similar to k, there's a minus k over here. K is already getting multiplied by this j, but k also needs to get multiplied by minus 1 to get this minus k. So essentially, we turn this into this, j minus 1 times k minus 1. And if you FOIL this out, you'll get jk minus j minus k, but there's also a plus 1. But we don't want that plus 1. This is just jk minus j minus k, not jk minus j minus k plus 1. So let's subtract a 1 from here. And now this is identical to jk minus j minus k. And again, this was equal to 0. Let's add 1 on both sides to get 1 equals j minus 1 times k minus 1. And now we can easily see our answers. J and k are both natural numbers. We know this because j is equal to x to the a, and both of these are natural numbers, so therefore j is a natural number. And the same thing for k. X and b are both natural numbers, and therefore k is a natural number. So the only way you can multiply two natural numbers together to get 1 is if both terms are 1. So that means j minus 1 has to be equal to 1, and k minus 1 has to be equal to 1. So if j minus 1 equals 1, then that means j equals 2. If k minus 1 is equal to 1, then that means k also equals 2. So we got our answers, j equals 2 and k equals 2. But we're not done yet. We have to solve for x, a, and b. So j was equal to 2. Therefore, 2 was equal to x to the a. Again, x and a are both natural numbers. So what does that mean? That means that there's only one set of integers that can be given to x and a. That is, x is equal to 2 and a is equal to 1. 2 to the power of 1 is the only way we can get 2 from two natural numbers like this. Therefore, x is equal to 2, a is equal to 1. And how about k? Well, k is equal to 2, and that is x to the power of b. And again, the only way you can have a natural number to the power of a natural number equaling 2 is if x was equal to 2 and b was equal to 1. So therefore, the only natural numbers that satisfy this x to the a plus x to the b equals x to the a plus b is x equals 2, a equals 1, and b equals 1. Circle this, and we are done.